Hi everyone, so today we're going to look at a review on function operations and compositions, and I want you guys to pause the video for a minute and try to warm up on your own first, and then you can go ahead and once you try to warm up, you can go ahead and skip over and fast forward the video a little bit to see if you get the correct answer, and if you got them all, then you can move on to the next part, and if you didn't get them all, then you can rewind and watch how I did some of these problems. Right, so f of 2, so you're given g of x, the function 5 over 3x plus 1, and you have f of x, which is the graph on the right, and you are trying to evaluate what f of 2 is. So I'm looking for, if I put 2 in for x into the f function, what is my output? So looking at my graph, when x is 2, y is at negative 2. So f of 2 is at negative 2. And f of 1, when x is 1, y is at, looks like y is at negative 3. Right here. So f of 1 is negative 3. And next you're looking for g of f of 0. So let's figure out what f of 0 is first. This right here. So f of 0, when x is 0, y is negative 2 in the f function. So really I'm looking for what is g of negative 2, because f of 0 is negative 2. And so now we're going to use the equation, because I don't have the graph for g. So g of negative 2 tells me I'm going to put negative 2 in as the input for x and simplify. So that's going to give me negative 6 plus 1, 5 over negative 5, which will be negative 1. So g of negative 2 is negative 1. And then the last one, g of f of 1. So f of 1 we said was negative 3 earlier. So I'm really looking for g of negative 3. If I put negative 3 in for x as the input, what's my output for the g function? So let's go ahead and calculate that out. G of negative 3 means I'm going to put negative 3 in for x and evaluate. So that's going to be 5 over negative 9 plus 1. That will give me negative 5 over 8. Alright, so evaluating functions using a graph and using an equation. And so today we're going to look at adding, subtracting, multiplying, dividing different functions. So operations, add, subtract, multiply, divide of different functions. The sum of f and g, so given any two functions f and g, the sum of f and g, we call this function f plus g of x. It's just a notation, just a name. So instead of adding the f function and the g function and calling it a new name like h of x, which you could, instead we would just write it as f plus g of x so that you know that's how I got that function, by adding f and g. And so similarly, if I subtract two functions, f of x minus g of x, I could name that new function f minus g of x instead of calling it a new name like w of x. And then similarly with multiplying, if I multiply f of x times another function g of x, the result of that, I can name this new function f times g of x. Similarly, I could also name it by a different letter, like L of x. Okay, and then lastly, when we're dividing, when we divide two functions, f divided by g, the result of that, we name this f divided by g of x. The only condition, because I am dividing and we have a fraction, is that my denominator is not 0, so g of x cannot equal 0. So let's do some practice. In example 1, we're going to assume that f of x equals x plus 1. and g of x equals x squared minus 1. And so we want to find the new function that is a result of adding the f function and the g function. So we call that f plus g of x. So just remember that this right here is just the name of my function. It does not mean I'm gonna add f plus g and then times x. That's not what it means. All this means is I'm going to create a new function by adding f and g, and the input for that new function is just x. Okay, so this is going to equal just adding two functions, so adding f and g. X plus 1 is my f function, plus my g function is x squared minus 1. Okay, adding that up and then combining like terms and putting it in standard form. I have x squared plus x, and then positive 1 and negative 1 adds to 0, so this is it. In B, we're going to subtract, so I want the function f minus g of x. That is a result of subtracting g from f. So that would be x plus 1 minus g of x is x squared minus 1. And it's important that you put the parentheses because you have to remember to distribute your minus. You're subtracting not only x squared but also the negative 1, so it becomes a plus 1. So then, rewriting this into standard form, I have negative x squared plus x plus 2, and this is my new function, which I'm going to call, instead of calling it a new name like h of x, I'm calling it f minus g of x. So as a result of subtracting g from f. And then multiplying, I'm going to multiply x plus 1 times x squared minus 1. And we're going to just distribute, do my double distributing. X times the x squared, x times negative 1, 1 times x squared, 1 times negative 1. Basically, you're doing your foiling. So that's going to be x cubed minus x plus x squared minus 1, and putting this into standard form so that it is in order from highest degree to lowest degree. X cubed plus x squared minus x minus 1. And then lastly, we're going to go ahead and find a new function that is a result of the quotient of f of x and g of x. So this is going to be equal to f of x in the numerator, and then g of x in the denominator, and we're going to try to simplify it if we can. So it looks like the denominator is factorable. That's a difference of two squares. Factors out to x minus 1 and x plus 1, which case we can cancel out a factor of x plus 1 on the numerator and denominator, and we're going to simplify this new function into just 1 over x minus 1. Alright, so just be very careful of the notation. Very common mistake is for students to think that I'm going to subtract f minus g and then I'm going to times everything by x. That's not what this x means. That x just means that your input in your new function is x. Okay, if this was right here, if this was instead of an x, a 2, for example, if this was a 2 instead of an x, that would mean after I subtract and I get my new function, instead of x, my input is gonna be 2. That's all that means. So that tells you what your input is. Okay, and then the very last thing that we're going to go over that you might recall from last year is composition of functions. And all that is when you compose functions, you're putting one function inside another. And there's two notations for it. The notation with the little open circle we call this f of g, so we say this as f of g, and we read this one the exact same way. Just two different ways of writing it, it means the same. You're always putting the one on the right inside the one on the left. So we're putting g inside f if it's written like that, and this is in function notation, seeing that the g of x is inside the f function. So as an example, if f of x is x plus 1 and g of x is 2x minus 1, to find f of g, we're going to put the g function as the input into the f. So all we're doing is in your f function, instead of x, I'm going to take g of x, which is 2x minus 3, and I'm going to put it in as the input into the f function. So that would be 2x minus 3. Your output is not just x, a variable, is an expression. So 2x minus 3 and then plus 1, and we simplify. So then similarly, if I want to do the reverse and find g of f, now I'm going to try to put the f function in as the input into the g function. So I'm going to take the f function, which is x minus 1, and I'm going to replace the x in the g function with my new input, which is x plus 1. And then we simplify. The only thing that you have to remember that's new is that when you are doing function composition and you're looking for the domain of your function, the resulting function, you gotta remember that the domain of the inside functions must always be part of the final domain. So these are the inside functions right here. If there's any restrictions for x in these inside functions, it must also be included in the final domain of your final function, even after it's simplified. So for example, if we look at example 2, we have f of x is equal to the square root of x, and g of x is x squared. So if I'm looking for g of f of x, my input for g is really f of x, which is the square root of x, right? That's what I'm putting into my g function. So my g function is normally my input x squared, but instead of x, we're going to put in the square root of x. Okay, and then we simplify, and when we simplify, we know that the square root and the square cancels each other out, and we just get x. And this is my function, g of f of x is just equal to x after I simplify. And if I'm looking for the domain of this, so g of f of x, after everything gets simplified, is just equal to x. And if I'm looking for the domain of this function, normally when I just look at the x, I would say, well, there's no restrictions for this x. Which is true, there's no restriction for y equals x. However, because there was a restriction in my inside function, there is a restriction for f of x equals the square root of x, that restriction has to apply, all right? So normally for this function, y equals x, my domain would be from negative infinity to infinity, but because f of x is the inside function, we are restricted by what the domain for the square root of x is. And we know that if x is inside a square root, it can't be negative, otherwise it's not real. So we say that the domain, smallest that x can be a 0 or positive. So the domain is from 0 to infinity. Okay, and so this is the domain that we're going to be using because it's restricted by what's in the inside function as well. So now again, I want you guys to try to pause this video for a few minutes and try this on your own, and then you can fast forward a little bit to see if you get the right answers. And if you did, you can move on, and if you didn't, then you can rewind and watch these parts again. So you have three functions, f of x, g of x, and h of x. And in A, it's asking you for f of 2a. So we call the functions different names so we can differentiate what function I'm using. In this case, I'm going to be using f, and I'm going to put 2a as my input. So instead of 9 over x plus 1, instead of x, I'm going to replace the x with 2a. And there's nothing else I can simplify, so that is it. Let's look at B. B, I am putting h inside g. So my g function, which is normally the square root of whatever x is, minus 1. Instead of x, my new input is going to be my h function, 9x squared plus 1. Because I'm putting the h into the g function as the new input, and then we simplify. Square root of 9x squared plus 1 minus 1 is just 0, so that cancels out. And the square root of 9x squared is 3x. Okay, and then let's look at C, f of 0. Okay, that I can evaluate. H of x I can't evaluate because there's nothing else to simplify, and my input is a variable. But f of 0, that we can figure out first. F of 0 would be 9 over 0 plus 1, which is just 9. And then I'm evaluating g of f of 0 we figured out was 9, so I'm really trying to figure out what g of 9 is. So that's going to be the square root of 9 minus 1, square root of 8, which we can simplify. 8 is 4 times 2, the square root of 4 is 2, so 2 radical 2. And then finally you have h of g. This tells me that I'm going to put the g inside the h function as the new input. Okay, so normally my h function is 9 times whatever the input is squared plus 1. And my new input, instead of x, I'm going to put in the g function, which is the square root of x minus 1. And then we simplify. Square root and square cancels out. I just have x minus 1. Distribute. And simplify. Okay, so if we look at these 4 answers, notice that when my input has a variable, my output also has a variable. My input has an a, my output has an a. My input has an x, my output is going to have an x. Okay, same thing here. My input's an x, my output is going to be an expression of a variable. C is the only one where my input is just a number, not a variable, and my output is just a number. So I would like you guys to work on the classwork/homework for the rest of class, and then the answer key will be posted later tonight.